Now let's move to the scheduling architecture. The scheduling architecture proposed in this work builds on the findings of a previous work that was proposed for a single factory with flexible resources. By definition, scheduling is an intermediary between planning and shop floor control, aiming at allocating the planned jobs to the shop floor resources. That's why the architecture is based on mapping planning and shop floor control into scheduling into main layers, and decomposing the scheduling problem into agents incorporated in at these two different layers of abstraction. The lower layer is decomposed further into two sub-layers consisting of agents representing resources and the services, and similarly the upper layer, the planning layer, is decomposed again into two sub-layers with agents representing customers and jobs. Schedules are generated through the goal-oriented interactions and negotiations between these agents. The agents are further connected to a repository corresponding to an environmental model representing or keeping the relevant scheduling data of all the entities of concern. All the static factors affecting production flow are kept here, and by this the factors are taken into consideration. This work was implemented using LSTS or under LSTS platform from Whitestein, and tested on different factory settings using plant simulation. The test results have shown that this way of generating the scheduling reduces the scheduling complexity drastically, so the schedules are generated with high reactivity, and they prove to provide very good efficiency in terms of the identified set of criteria. In addition, the factories identified using this way can be defined and extended dynamically, so long-term flexibility is also ensured. That's why we extend this framework here in this work for multi-factory make-to-order settings by first adding here a layer that takes care of the distributed manufacturing facilities. So we have here the facilities layer, which incorporates agents of 4 different types identified from the previous analysis and corresponding to the material supplier, the shipping company, the factory, and the warehousing company. These agents integrate themselves with the other agents through dynamic negotiations and monitor their corresponding physical entities, and by this we take care of the identified dynamic influencing factors. So through this real-time monitoring and the tracking, we can generate schedules under consideration of the dynamic influencing factors. Next, cloud providing pervasive make-to-order support is defined and linked to these agents. So let's, in the next slide, look more thoroughly into this cloud. The contents of the cloud is basically the agents. First, these agents identified at the 2 upper layers. They are incorporated here first to represent the customers and their instantiated jobs. These agents are linked to an environmental model extended from the previous work, so containing not only data about resources and services, but also about the whole facilities, and also customer profiles along with products. So we have to add also tools for configuring pro and personalizing products, identifying them. Also another tool for searching for agents and facilities and so on. It has to be has to use Yellow Pages database for keeping track of all identified agents and their supported services. And finally, there is a configuration and administration tool for configuring agents as well as services and any factory related data dynamically. So let's here move on to how scheduling takes place. Scheduling is performed as follows. First, agents, there is a customer agent for every place, so we will move this